Dear students, today we will discuss what is a quadratic equation. You are aware of it, that what is quadratic equation, because we have learned it in class 10th. In class 10th, we have discussed the real roots and the real coefficients. But in class 11th, we will discuss the real coefficients with imaginary roots or the complex roots. Before we will start, let us discuss what is actually a quadratic equation. The general form of the quadratic equation is ax square plus bx plus c is equal to 0. This is the general form of the quadratic equation, where a, b and c, these are known as the real numbers and the degree of the variable is 2. But here is a condition that a should not be equal to 0. If a will be equal to 0, then it will no longer be a quadratic equation, it will become a linear one. So, this quadratic equation has real roots now the real roots of the quadratic equation, how many real roots are there? Since the degree of the variable is 2, this indicates that this particular quadratic equation will have 2 roots. Now let us take an example and see that how we can say that this particular quadratic equation has got 2 real roots. Now let us discuss about the roots of the quadratic equation. Ax square plus bx plus c is equal to 0, where a is not equal to 0 is a quadratic equation. We can say ax square plus bx, you can transpose this c to this side. Now we can add, or we can say dividing both sides by the coefficient of x square, that is by a, what we will get? Ax square divided by a plus bx divided by a is equal to minus c divided by a. Or we can say it is now x square plus b by ax is equal to minus c divided by a. Now the next step, this is actually the method of completing the square. So in the first step, we have to make the coefficient of x square as a unity, and in the second step, we have to add half of coefficient of x, but it should be the absolute value. Half of coefficient of x whole square on both sides. What will be the result then? The result will be, if we will add half of, that is adding 1/2 of coefficient of x whole square, but it should be the absolute value on both sides. We get x square plus b by ax plus 1/2 of, what is coefficient of x here? That is b divided by a whole square is equal to minus c by a plus 1 by 2 into b divided by a whole square. Can we say it is x square plus b divided by a of x plus b1 is b divided by 2a whole square is equal to minus c by a plus b divided by 2a whole square. We can say it is x square plus b divided by a of x plus b divided by 2a whole square equal to minus c by a plus it is b square divided by 2 square is 4 and it is a square. Now this is x square plus b by a of x plus b divided by 2a whole square. We can write it in the form of a plus b whole square, or sometimes we can say it may be a minus b whole square. Since all the three terms are here positive, so it is x plus b divided by 2a whole square. You can check it out that it is a plus b whole square means a square, that is x square, plus b square means b by 2a whole square plus 2ab. 2 into x into b by 2a, 2 and 2 will get cancelled, then it will be b divided by a of x. That is equal to minus c divided by a plus b square divided by 4a square, right? Now we can say it is x plus b divided by 2a whole square. When it is x plus b divided by 2a whole square equal to, you can take 4a square as the LCM factor. So it will be minus 4ac plus it will be b square. Or we can say x plus b divided by 2a will be equal to square and it is b square minus 4ac. This means that we have to cancel the square here. We have to take the positive square root, but it should be plus and minus under root of b square minus 4ac divided by 4a square. Dear students, do you know why it is plus and minus? Okay, why it is plus and minus? Before we will go through this question, let me tell you what actually this plus and minus is. This is the important part. Suppose we have an example, x square is equal to 4. So it is better to write x square, you can transpose this 4 here, it will be x square minus 4 equal to 0. Can we say it is x square minus 4 means 2 square is equal to 0. So this is an identity. A square minus b square. A square minus b square is simply a plus b, a minus b. That is x plus 2 into x minus 2 equal to 0. This x plus 2 and x minus 2 are said to be the two factors of the quadratic equation. And both factors cannot be equal to 0 simultaneously. Either this should be equal to 0 or this should be equal to 0. So when this is equal to 0, x plus 2 is equal to 0 means x is equal to minus 2 and here x will be equal to plus 2. So x has got two values, plus 2 and minus 2. That is why we can say it should be plus and minus. Second part, since it is a quadratic equation and in a quadratic equation it has always two roots. So plus and minus under root of b square minus 4ac divided by this. Can we say now it is x plus b divided by 2a equal to plus and minus square root of b square minus 4ac. If we will change square root of 4a square, we can write 4 is the square of 2 and instead of a square we can write a. We have to find the value of x or we can write it x is equal to this b by 2a, you can transpose it. It is minus b divided by 2a plus minus square root of b square minus 4ac divided by 2a. It is divided by 2a. Or we can say x is equal to, since the denominator is same, we can write x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. This indicates that x has got two values. One is minus b plus square root of b square minus 4ac divided by 2a, and the second one is minus b minus square root of b square minus 4ac divided by 2a. These are said to be the two roots of a quadratic equation. But both roots, are they real roots or they complex roots? It can be written like this. We can write it like this. X is equal to minus b plus this b square minus 4ac. It is denoted by a letter d, where d indicates that it is the discriminant. So plus square root of d divided by 2a, and it is minus b minus square root of d divided by 2a, where d is equal to b square minus 4ac. So these are the two roots of the quadratic equation. Now what is the sum of the roots? If we will take the sum of these two roots, what will be the result? You will see the sum of the roots will be always equal to minus b divided by a. Now it is the sum of roots. Sum of roots. It is equal to minus b plus square root of d divided by 2a plus minus b minus square root of d divided by 2a. It is equal to, since the denominator is again same, it is 2a, so it is better to write minus b plus square root of d plus minus, it is minus b and it is minus square root of d, plus square root of d and minus square root of d, that will get cancelled. So it is minus b and minus b, it will be minus 2b divided by 2a. 2 and 2 will get cancelled, so it is minus b by a. So sum of the roots is minus b by a. You know that in a polynomial, the sum of the zeros was minus coefficient of x divided by coefficient of x square. Is it? Minus b by a. If the general form is ax square plus bx plus c is equal to 0, then the sum of root is again negative of coefficient of x divided by coefficient of x square. So in a polynomial, we have written it, it is negative of coefficient of x divided by coefficient of x square. Here we have proved it that it is definitely equal to minus b divided by a, that is the sum of the zeros. Or in a quadratic equation, we can say it is sum of roots. Now what will happen if we will take the product of the roots? It is sum of roots. Now let us discuss the product of roots. You know that the two roots of the quadratic equation were in the form of negative b plus square root of d divided by 2a and minus b minus square root of d divided by 2a. What is the product of roots? That is, product of roots is equal to minus b plus square root of d divided by 2a into minus b minus square root of d divided by 2a. Can we say it is a plus b into a minus b. What is a plus b into a minus b? It is a square minus b square. That is minus b whole square minus square root of d whole square divided by 2 into 2 is 4 and it is 4a square. It is negative square is positive b square minus square and root will get cancelled, so it is d divided by 4a square. Now we have to put the value of d as b square minus 4ac, because discriminant is always equal to b square minus 4ac. So can we say it is b square minus, instead of d we can write b square minus 4ac divided by 4a square. It is b square minus b square minus minus it is plus 4ac divided by 4a square. This will get cancelled, so it is 4ac divided by 4a square. 4 and 4, a and 1a will get cancelled, so the net result will be c divided by a. What is c divided by a? It is simply constant term divided by coefficient of x square. So it was about the sum of the roots and the product of the roots. Then the second part of it is about the nature of the roots. If this discriminant is greater than 0, we can say that it has real roots, but the two roots are totally different. They are distinct. When discriminant is equal to 0, it has real roots, but both are equal. And now, when discriminant is less than 0, what about the nature of the roots? Let us discuss this. When discriminant is less than 0, it will have real coefficients, but it has imaginary roots, or we can say it has complex roots. What are these complex roots and how we can prove these questions when the discriminant is less than 0? Let us take an example and say x square plus 4 is equal to 0. Can we say x square 4 you can transpose it, or we can say it is equal to negative 4. X square will be equal to 4 and we can write it minus 1. X square we can say 4 and this negative 1, actually in a complex spot we can say square root of minus 1 is denoted by a letter that is known as iota. This is iota. And iota is always equal to square root of minus 1. That is 4 into square root of minus 1. If we will take the positive square root here, so under root of minus 1 will be equal to, if you will take the squaring on both sides, minus 1 will be equal to iota square. So it is 4 iota square. So x square is equal to 4 iota square. X is equal to squaring, so you can take positive and negative, it will be equal to square root of 4 iota square. X will be equal to plus minus square root of 4 will be 2, iota square will be iota. So x has got two roots here, plus 2 iota and it is minus 2 iota. So this plus 2 iota and minus 2 iota, these are the two roots of a complex quadratic polynomial having complex roots. Now let us take an example. 4x square plus 9 equal to 0. We have to solve this equation by factorization method. That is 4x square plus 9 is equal to 0. How you can go to solve through this? Can we say it is 4x square minus into minus 1 into minus 9 equal to 0. When it is 4x square plus 9 is equal to 0, we can say it is 4x minus 1 into minus 9 is equal to 0, result will be same. Or can we say it is 4x square minus 9 iota square equal to 0? Is it so? Why? Because when iota is equal to square root of minus 1, if you will take the square root, positive square root, squaring on both sides you can take, so minus 1 will be equal to iota square. So instead of minus 1 you can write iota square and minus 9 will be same. So it is now 4x square minus 9 iota square equal to 0. Can we write it like this? 4x square means 2x whole square minus 9 iota whole square means 3 iota whole square, that will be equal to 0. So this is again in the form of a square minus b square. What is a square minus b square? That is a plus b, that is 2x plus 3 iota into 2x minus 3 iota equal to 0. These are said to be the two factors, and both factors cannot be equal to 0 simultaneously. Either this will be equal to 0 or this will be equal to 0. This part you know, that is the net result will be equal to, x will be equal to, if you will transpose this 3 iota, it will become minus 3 iota divided by 2, and the second part will be equal to 3 iota divided by 2. So these are said to be the two roots of the given equation. Now if we will take one more example, that is x square minus 4x plus 13 equal to 0. X square minus 4x plus 13 equal to 0 by the factorization method. How you can go to solve through this? Can we say it is x square minus 4x, this 13 we can write it plus 4 plus 9 equal to 0, because we have split it 13 into two parts. 13, that is 4 plus 9. Why? Because we can take these three terms into consideration. That is x square minus 4x plus 2, that will be a minus b whole square, or we can write it x minus 2 whole square. It is x square plus 2 2s are 4 minus 2ab is 4x plus 9 will be 3 square equal to 0. So when it is x minus 2 whole square plus 3 whole square is equal to 0, can we write it that is x minus 2 whole square plus 9, but we have to write it in the form of a complex part. We have to introduce somewhere iota. So plus 9, can we say it will be minus 9 iota square? It is better to write like this. Plus 9, that is minus 9 iota square equal to 0. Now it is better to eliminate this step like this, or it is x minus 2 whole square minus 9 iota square will be now 3 iota whole square equal to 0. It is again a square minus b square, that is x minus 2 plus 3 iota, and the second will be x minus 2 minus 3 iota equal to 0. So what will be the result? Either this is equal to 0 or this is equal to 0. That is either x minus 2 plus 3 iota will be equal to 0. This indicates that x will be equal to minus 2, it will become plus 3 iota will be minus 3 iota. Or the second part, that is x minus 2 minus 3 iota is equal to 0, means x will be equal to 2 plus 3 iota. So this 2 plus 3 iota and 2 minus 3 iota, these are said to be the two roots of this quadratic equation having complex roots. Now one more. If this is the quadratic equation having complex roots, but what will happen if we will get a quadratic equation like this: x square plus 5x plus 6 is equal to 0. In previous two questions, we have find the roots of the quadratic equation having complex part, but this is a quadratic equation having two real roots. Like it is x square, instead of 5x we can write 3x plus 2x plus 6 is equal to 0. You can take x as a common factor. You are quite aware of it. It is an easy example for you people to learn. That is equal to 0. That is x plus 3 and x plus 2. That is equal to 0. Either this is equal to 0 or this is equal to 0. We can say that is x will be equal to, it is minus 3 and minus 2. So when it is minus 3 and minus 2, the topic we have learned before, that is the sum of the roots and the product of the roots. You can check it that if you will take the sum of these two, negative 3 and negative 2 will be negative 5. That is always the negative coefficient of x, and the coefficient of x square is 1. And if you will take the product of the roots, that is negative and negative is positive, 3 2s are 6. That is C divided by A. So sum of roots verified, product of the roots are also verified. Now, there are some examples for you people that how you can solve the quadratic following equation by factorization method having the complex part. That is x square minus square root of 2 iota into x plus 12 is equal to 0. This is the equation, and we have to find out its roots. We have to solve it by the factorization method. How you can solve this? Can we say it is x square minus, it is root 2 iota into x plus 12. This 12 we can change it, minus root 2 iota, we can write it minus 3 root 2 iota plus 2 root 2 iota or 1 root 2 iota. How it is 3 root 2 iota plus 1 root 2 iota? It is 3 minus 1, that is minus root 2, and it is root 2 iota is same. That is 3 2 root iota is rather 3 minus 2, that is minus 1, root 2 iota will remain same because we cannot add two different irrational numbers, and it is minus 3 root 2 iota plus 2 root 2 iota. These are the two parts. Minus plus 12 means it will be minus 12 iota square. Because it is minus 12, iota square is minus 1, minus minus it will be plus 12. That is equal to 0. So these are the four terms, 1, 2, 3 and 4. Now we can factorize them, and you know better that how we can factorize these quadratic equation. If in these two terms it is x here and it is also x. If you will take x as a common factor, it is x minus 3 root 2 iota. Here you can take the common factor as, because it will be plus 2 root 2 iota here, and it is x because it will be 2 root 2 iota x, it is minus, then 2 root 2, and here we can write 3 root 2. It is 2 3s are 6, root 2 and root 2 will be 2, 6 2s are 12, it is iota, that is equal to 0. Now this x minus root 3 iota and this x minus root 3 root 2 iota, take it as a common factor. We can write it x minus 3 root 2 iota 1, and the second one will be x plus 2 root 2 iota, that will be equal to 0. Can we say this x will have two roots now, x will be equal to 3 root 2 iota, and the second one will be x minus 3 root 2 iota is 3 root 2 iota, and the second one will be minus 2 root 2 iota. These are the two roots of this quadratic one. Let us take one more example having quadratic equation with complex roots. 3x square plus 7 iota x, 3x square plus 7 iota x plus 6 equal to 0. This is another equation, and we have to solve, we have to find out its roots by factorization method. Can we say it is 3x square plus this 7 iota x, we have to change into two forms, that is 7 iota x can be written as 9 iota x minus 2 iota x, that is 9 minus 2 is 7 iota x, and this plus 6 we can write minus 6 iota square is equal to 0. Now you can take 3x as a common factor. It will be x plus it is 3 iota, that is 3x square plus 9 iota x minus 2 iota you can take as a common factor. It is x plus 3 iota equal to 0. That is x plus 3 iota into 3x minus 2 iota, it will be equal to 0. This indicates that x will have two roots, that is minus 3 iota and 2 iota divided by 3. These are the two roots of this complex number. So this was all about how we can find out the roots of a quadratic equation having the complex part. Now, the second part of this quadratic equation is how you can find out the roots by the quadratic formula. Find real theta such that 3 plus 2 iota sine theta divided by 1 minus 2 iota sine theta is purely real. So we have to find real theta such that 3 plus 2 iota sine theta divided by 1 minus 2 iota sine theta is purely real. This means that there should be no sign of iota. So if we will take 3 plus 2 iota sine theta divided by this, how you can solve this? We will rationalize it. Can we say it is 3 plus 2 iota sine theta divided by 1 minus 2 iota sine theta? By rationalizing it, we can multiply it by 1 plus 2 iota sine theta divided by 1 plus 2 iota sine theta. So this denominator part, we have to rationalize it. Now you can simply take the multiplication factor. 3 1s are 3 plus 3 2s are 6 iota sine theta plus 2 1s are 2 iota sine theta plus 2 2s are 4 iota square sine square theta whole divided. And you know that it is again, when you will rationalize any part, rationalize the denominator. Denominator is always in the form of a plus b into a minus b. That is a square, and it is minus 2 iota sine theta whole square. So the next part of this is 3 plus 6 iota and 2 iota, that will be 8 iota sine theta. It is plus 4 iota square will be minus 4 sine square theta whole divided by 1 square is 1 minus 2 square is 4, then it is iota square and it is sine square theta. That indicates that it will be 3 minus 4 sine square theta plus it is 8 iota sine theta whole divided by 1 iota square is negative 1 minus minus it will be plus 4 sine square theta. Can we say this particular part can be written in the form of 3 minus 4 sine square theta divided by 1 plus 4 sine square theta plus 8 iota sine theta, 8 iota sine theta divided by 1 plus 4 sine square theta. So this part is the purely real part and this is purely imaginary part. Question was find real theta such that this is purely real. So when it is purely real, it is 3 plus 2 sine theta divided by 1 minus twice iota sine theta. Agar ye pure real hona chahiye, so this indicates that when it is purely real, therefore the imaginary part is 0. Imaginary part is this. So for purely real, it should be equal to 0. For purely real, this part 8 iota sine theta divided by 1 plus 4 sine square theta, that should be equal to 0. Can we say 8 iota sine theta is equal to this into 0? Here sine theta will be equal to 0 divided by 8 iota. That is sine theta will be equal to 0 divided by 8 iota and that is always equal to 0. So it is 8 iota sine theta is equal to 0 divided by 8 iota, or we can say sine theta is equal to 0 here. So when sine theta is equal to 0, this indicates that sine theta, when it is equal to 0, we can say theta is always equal to 0, because when sine theta is equal to 0, sine 90 is equal to 1 and sine 0 is equal to 0. So the value of theta is equal to 0. When it is purely real, then theta is always equal to 0. Now, the most important part, that is if z, the complex number, is 2 minus 3 iota, then we have to show that z square minus 4z plus 13 is equal to 0 if z is a complex number, and if this complex number is equal to 2 minus 3 iota, then we have to show that z square minus 4z plus 13 is equal to 0, and hence find the value of 4z cube minus 3z square plus 169. Can we say z is equal to 2 minus 3 iota? Here z minus 2 solution. Here z is equal to 2 minus 3 iota. In the first part you can transpose this 2. So it is z minus 2 is equal to minus 3 iota. When z minus 2 is equal to minus 3 iota, now you can take squaring on both sides, or we can say squaring on both sides. So it is z minus 2 whole square is equal to minus 3 iota whole square. So when it is z minus 2 whole square is equal to this, it is z square plus 2 square is 4, 2ab will be 4z, it is equal to 9 iota square. So can we say it is z square minus 4z plus 4 equal to 9 iota square will be 9 into minus 1. It is z square minus 4z plus 4. This plus minus is minus 9. You can transpose it that is equal to 0. That indicates that it is z square minus 4z plus 9 plus 4, 13 is equal to 0, what we have to get. So the result is z square minus 4z plus 13 is equal to 0. This means that when z is equal to 2 minus 3 iota, we can find out the value z square minus 4z plus 13 is always equal to 0. Now we have to find the value of 4z cube. In the same question, we have to find the value of 4z cube. Now we have to find the value of we have to find the value of 4z cube minus 3z square plus 169. What we can do, it is we can take 4 as a common factor. When it is 4z cube minus 3z square plus 169, we can write it 4z. You can take z square as a common factor here. 4z into z square will be 4z cube. Then it is minus 4z plus it will be 13 plus 13 you can take again as a common factor. Then you can write z square minus 4z plus 13. When it is 4z into z square, it is 4z cube. 4 4s are 16z square, but it is 13z square. 16z square minus 13z square will be 3z square. 4 13s are 52z, and it is 13 4s are 52z, that will get cancelled. 13 and 13 will be 169. So can we say it is 4z. Z square minus 4z plus 13 is equal to 0. So it is better to write 0 plus 13. Again z square minus 4z plus 13 is equal to 0. So it is 4z into 0 is 0 plus it is 0. 0 plus 0 is again 0. So we can say z cube 4z cube minus 3z square plus 169 is always equal to 0. So this was all about the roots of a complex number. Now, complex numbers. So we have find out the roots of the quadratic equation having real roots, and we have discussed the quadratic equation having the complex roots. Now, what is actually this complex number? What is difference between this complex number and the equation having the real roots? This complex number is always denoted by z, and z is always in the form of a plus iota b, where this a is said to be the real part and b is said to be the imaginary part. When z is equal to a plus iota b, then it is conjugate, that is z conjugate is in the form of a minus iota b. If we have to find out, if we will express it in the form of a plus iota b, can we say if it is minus 5 iota into 1 divided by 8 iota, how you can write it in the form of a plus iota b? So what we have to do, we have to simply take the product form. So negative 5 divided by 8, it is iota into iota, it is iota square. But you are aware of it, that is minus 5 by 8, iota square is always equal to minus 1. So it is minus minus, it is plus 5 by 8, but it is purely real. But we have to write it in the form of a plus iota b. So can we say a is 5 divided by 8 plus we can write 0 into iota. So it is a plus iota b, means a is equal to 5 by 8 and the value of b is equal to 0. So any complex number, we can write it in the form of a plus iota b, where a is said to be the real part and b is said to be its imaginary part. Let us take an example and see what will be the value of this. Iota raised power 9 plus iota raised power 19. Iota raised power 9 plus iota raised power 19. Before we will go through this, let us start from the very beginning. That is, we know that iota is equal to square root of -1. Iota square will be equal to -1. Then iota cube will be equal to iota square into iota. Iota square is -1 into iota, it is minus iota. What about iota 4? We can write iota square whole square. Iota square is -1 and it is -1 square, it will be +1. Then it is iota raised power 5. We can write iota cube into iota square. Iota cube, we have got the value of minus iota. Iota square is -1, so it is plus iota. And it is iota raised power 6. It is iota square raised power 3. Iota square is -1 raised power 3, so it will be -1. And if you will take iota 7, it is iota 4 into iota 3. Iota 4 you have got the value of 1, and iota cube it is minus iota, so it is minus iota. And last it is iota 8. Can we say it is iota square raised power 4? Iota square is -1 and it is raised power 4, so it is 1. Now you can check. Iota square is equal to -1. Iota 4 is equal to 1. Iota 6 is equal to -1. Iota 8 is equal to 1. And when you will take the cubes, iota cube minus iota, iota 5 iota, iota 7 minus iota, 9 will be iota, 11 will be minus iota, and 13 will be iota. So what is iota raised power 9 into iota raised power 19? Can we say it is iota square raised power 4 into iota plus iota square raised power 9 into iota. Iota square is -1 raised power 4 into iota. Iota square is -1 raised power 9 into iota. -1 raised power 4 is 1 into iota is iota. -1 raised power 9. What is iota raised power -9? It is iota -1 raised power 9 is -1. That is minus iota. So plus iota and minus iota, that will be always equal to 0. So what is iota raised power 9 and iota raised power 19? If you can write it in the form of a plus iota b, we can write it is 0 plus iota into 0, or 0 plus 0 iota. This is how we can show iota raised power 9 plus iota raised power. Now if you will take this iota raised power 9 plus iota raised power 19, it is better to write it iota raised power 4 whole square. Iota 4 raised power 2 into iota, because it is in the form, either in the form of 4k or 4k plus 1, 4k plus 2 or 4k plus 3. Now what will happen if we have to find the value of iota raised power -39? Iota raised power -39. So we can write it iota raised power 4 raised power, we can say it is -10. So it is iota raised power -40 here. Into iota. Iota raised power 4 into -10. That is iota raised power -40 into iota raised power 1. So -40 iota raised power 1, that will be iota raised power -39. What is iota raised power 4 equal to? Iota raised power 4 will be always equal to, that is iota 1, and 1 into iota, that is equal to iota. We can write it, it is 0 plus 1 iota. So -1 Again, or if you will take it like this, iota square raised power minus 19, that is minus 38 into iota, or it is better to write like this, iota raised power minus 9 means 1 divided by iota raised power 39. It is 1 divided by iota square raised power 19 into 1 divided by, it is 38 and it is 1 iota. It is 1 divided by iota square is minus 1. So minus 1 raised power 19 will be minus 1 and it is iota. So you can rationalize it by minus iota and minus iota. It is minus iota, it is minus plus iota square. It is minus, it will be minus iota, iota square is minus iota divided by minus 1. Negative and negative will get cancelled. It is again iota. So if you will take iota raised power 4 into consideration, or you can take iota square also into consideration. Now express 3 of 7 plus 7 iota into this in the form of a plus iota b. 7 plus 3 iota plus iota of 7 minus 3 iota in the form of a plus iota b. So can we say its solution is like this, 3 7s are 21, 3 3s are 9 iota, it is 7 iota minus it is 3 iota square. It is 21, 9 iota plus 7 iota will be 16 iota, minus 3 iota square will be plus 3. That indicates that 21 plus 3 is 24 plus 16 iota. So this is again in the form of a plus iota b. It was the simplest part. Now we can take how we can write it in the form of a plus iota b when it is in the form of 1 plus 3 divided by 3 iota whole cube. Again we have to write this part in the form of a plus iota b, but you are aware of it that this is the general formula of a plus b whole cube. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. That is, a cube means 1 by 3 cube plus b cube means 3 iota whole cube plus 3ab into a plus b. Can we say it is 1 cube, 3 cube is 27, 3 3s are 9, 3s are 27 iota cube, plus 3 and 3 will get cancelled, so it is 3 iota, it is 1 by 3 plus 3 iota. It is 1 divided by 27 plus 27 iota cube is 27 iota square into iota plus 3 iota into 1 by 3, 3 and 3 will get cancelled, so it is iota plus 3 3s are 9 iota square. So it is 1 divided by 27 plus 27 iota square is negative 1 plus it is iota plus 9 iota square will be minus 9. Can we say it is 1 divided by 27 plus minus minus 27 plus iota minus 9. Now we can write it in the form of a plus iota b. That is 1 divided by 27 minus 27 minus 9 plus iota. It is, you can take 27 as a common factor. It is 27, 1, that is LCM actually. 1 minus, what is 27 into 27? It is like this, 7, 49, 14 and 18 and 54. It is 9, 12, 6 and 7. That is 7, 2, 9 minus 9, 7, 63, 18 and 6, 24 plus it is iota. Now it is 1 minus, it is 9, 12, 4, 7, 6, 7 and 7, 9 divided by 27 plus iota. So the net result will be equal to, it is minus 971 divided by 27 plus 1 iota. So this is in the form of A plus iota B. So dear students, it is all about the first part of a complex part, and in the second part I will show you what is the multiplicative inverse of complex part and what is its conjugate.